Welcome to PRISCI Educational Academy, Avadi, Chennai. Today I am going to explain you the fourth problem of Fourier series. Obtain the Fourier series for f of x is equal to e power minus x in the interval 0, 2 pi. Given f of x is equal to e power minus x in the interval 0, 2 pi. Fourier series formula is f of x is equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. We have to find the Fourier constant of a naught, an, bn values. First, we will find what is the limit 0 to 2 pi, the interval is. So we are going to first to find the value of a naught. A naught is equal to 1 divided by pi integral over the limit 0 to 2 pi f of x dx, which is equal to 1 divided by pi integral over the limit 0 to 2 pi e power minus x into dx. You know very well, I think, integral e power ax dx is equal to e power ax divided by a. So e power minus x, if we are integrating, e power minus x divided by minus 1. X coefficient you have to write as in the denominator. So minus 1. So minus e power minus x. So 1 by pi minus e power minus x. The limit is 0 to 2 pi. First, you have to apply the upper limit for x. 1 by pi into minus e power minus 2 pi minus of e power 0. E power 0 value is 1. Minus of minus 1 will become plus 1. So 1 by pi, 1 minus e power minus 2 pi. This is a naught value. E power 0 is 1. Next, you have to find the an value. An is equal to 1 by pi integral over the limit 0 to 2 pi f of x cos nx dx. Then the next step, an is equal to 1 by pi integral over the limit 0 to 2 pi e power minus x into cos nx dx. What I said you already, I explained you. You cannot, here we cannot use the Bernoulli's formula. Why? Because e power minus x cos nx, e power minus x is not polynomial. Okay, so there should be x square cos nx, x cos nx. Understand? So x cos nx means u is equal to x, u dash, u double dash, u triple dash must become 0. Then only we can use the Bernoulli's formula. Here we cannot use the Bernoulli's formula. So there is another formula. Integral e power ax cos bx dx is equal to e power ax divided by a square plus b square. A cos bx plus b sin bx. This is the formula. So you can compare with the original formula. An is equal to 1 by pi integral over the limit 0 to 2 pi e power minus x cos nx dx. Comparing with the formula, for a here is minus 1, for b here is n. So answer is e power minus x. An is equal to 1 divided by pi into e power minus x divided by a square plus b square. A is minus 1, b is n. So 1 square plus n square, 1 plus n square into minus cos nx plus n sin nx. Limit is 0 to 2 pi. So 1 by pi into e power minus 2 pi divided by 1 plus n square into minus cos 2n pi, because apply the upper limit as well as lower limit. Minus cos 2n pi plus n into sin 2n pi minus e power 0 divided by 1 plus n square minus cos 0 plus n into sin 0. Sin 0 cancel, 0. Sin 2n pi value is 0. Cos 0, 1. Cos 2n pi value 1. So 1 by 1 divided by pi into e power minus 2 pi divided by 1 plus n square minus cos 2n pi. Cos 2n pi value 1 minus cos 2n pi value minus 1. plus 1 divided by 1 plus n square. So an is equal to 1 divided by pi into 1 minus e power minus 2 pi divided by 1 plus n square. So we cannot use the Bernoulli's formula here. That's why I solved this problem. So Bn is equal to 1 by pi integral over the limit 0 to 2 pi f of x sin nx dx, which is equal to 1 by pi integral over the limit 0 to 2 pi e power minus x sin nx dx. Here also the different formula integral e power ax sin bx dx is equal to e power ax divided by a square plus b square into a sin bx minus b cos bx. Here a is equal to minus 1, b is equal to n. So substitute in this formula, bn is equal to 1 by pi into e power minus x divided by 1 plus n square into minus sin nx minus n cos nx. Limit is 0 to 2 pi. So you have to apply the upper limit minus lower limit, which is equal to 1 by pi into e power minus 2 pi divided by 1 plus n square minus sin 2n pi minus n cos 2n pi minus into e power 0 divided by 1 plus n square into minus sin 0 minus n cos 0. Sin 0 0, sin 2n by 0, I have striked out. So cos 2n by 1, cos 0 1. So 1 by pi into e power minus 2 pi divided by 1 plus n square into minus n plus n divided by 1 plus n square. So bn value is equal to n divided by pi into 1 plus n square into 1 minus e power minus 2 pi. This is the bn value. Then answer, final answer is Fourier series value f of x is equal to a0 by 2. A0 is 1 divided by pi into 1 minus e power minus 2 pi divided by 2 plus summation n equal to 1 to infinity a n 1 minus e power minus 2 pi divided by pi into 1 plus n square into cos nx plus bn n into 1 minus e power minus 2 pi divided by pi into 1 plus n square into sin nx. So thank you all.